All right, today we are looking at the second half of lesson 6.3, rational coefficients, this time with decimals. In the last lesson, we talked about when the coefficients were fractions. Today we're going to talk about what happens if the coefficients are decimals, or if we're dealing with decimals maybe on the other side of the equation and trying to deal with those problems. So let's go ahead and dive in here, and let's take a look. So the first problem I have here is 0.8m is equal to 6.4. All right, so decimals are kind of harder to work with. They sometimes get a little bit confusing. So one of the main strategies that I like to use is to not have decimals at all. What do we mean? Well, one thing you could do is you have to remember that you can add as long as you can do anything you want as long as you do it to both sides equally for an equation. So if you want to add on both sides, that's what we did in the first lesson. If you want to subtract, if you want to multiply, if you want to divide, whatever you want to do, as long as you do the exact same thing on both sides, it's okay because the equation is still balanced. You still have the same thing on one side and the same thing on the other. So remember, we have two sides to our equation here. But this is what I'm going to do. I'm going to kind of use a hack a little bit here, and I'm going to say, you know what? I'm going to multiply both sides by 10 to both sides. Now, why would I do that? Well, think about it. If I multiply by both sides by 10, what happens? Well, remember when you multiply something by 10, it moves the decimal over one place to the right. 0.8 becomes simply 8. And so you're left with just 8m. And then 6.4 becomes 64. And now you've got kind of an easy problem. Say, oh, 8m equals 64? I can do that. That's not a problem. Next step I'm going to do, of course, is then I see that I'm multiplying by 8, so I'm going to divide by 8 on both sides. I'll use the fraction bar this time. And so my final answer is m is equal to 64 divided by 8 is 8. Now, of course, we need to check. So let's go ahead and check our work here. Going back to the original problem, I have 0.8 m is equal to 6.4. All right, so instead of m, I'm going to put 8, right? So 0.8 times 8 should equal to 6.4. Now remember, when you're multiplying with decimals, you just multiply by the exact regular amount as if the decimal is not there, and then you just add in however many decimal places there are. What that means is, look, there's only one number behind the decimal, so that means my final answer will have, I'll have one number over. I'll have one number, and then I move the decimal in one space. So I know that 8 times 8 is 64, but I need to move in one decimal place, so 6.4. And that checks out. So I know that my answer is m is equal to 8. So it's kind of a little trick to basically, when you have decimals, to not have decimals anymore. So let's go ahead and do another one of these problems. Right, so it's very similar. Let's just do one that's very similar. If I had 0.6a, right, is equal to, let's say, 4.8. So again, what I'm going to do is I'm going to multiply both sides by 10. On both sides, so times 10 times 10. That's going to move my decimal over one place on each. So you see, as long as it's being done equally, that's fine. And once you get really good at this, you can just move the decimal without even doing all the hassle there. So you get 6a is equal to 48. We know that then I can just divide by 6 on both sides. And I get my final answer of a is also equal to 8 in this case. So again, we're multiplying out so that we don't actually have a decimal coefficient. That's going to be the key, so that we don't actually have a decimal coefficient. So what would we do here? Let's say we had something like this. 0.05y is equal to the number 1. Okay, this one's a little bit trickier. So we got to think about it. In this case, in the first couple, we had to move the decimal just one place to get it out of the way, right? From 0.6 to 6. This time I have 0.05. So I got to think about it. I got to move the decimal actually once, twice, 2 places, which means I'm not multiplying by 10. I'm actually multiplying by 100. Now, what I do on the one side, I have to do on the other. And again, you move the decimal. So after 1 is 1, 2, fill in the zeros, you end up with the number 100, right? I multiplied by 100 there. I move the decimal over 2 spaces. So now my new numbers are 5y is equal to 100. You see that? So instead of 0.05 is equal to y is equal to 1, now it's 5y is equal to 100. And this is a problem that I can do, right? So I moved the decimal 2 places, which again is the same thing as multiplying by 100. And so you're going to either multiply by 10 or 100 or 1,000. If necessary, probably won't get much higher than that. And usually it's just 10 or 100, just so you can get the decimal out of the way. Okay, that's the goal you're trying to do, is get the decimal out of the way here. So next step, divide by 5, right? On both sides. And then with my final answer, which is y is equal to 20. And of course, if you want to check it, we can check it real quick. We have 0.05 times 20, which is our answer that we're guessing it is, or that we found, should equal our original number, which was 1. 20 times 5 is 100, but you have 2 decimal places, right? 1, 2. So I got to go back 2 decimal places. 1, 2. So my decimal should be right here. So 1.00, is that equal to 1? Yeah, that works out. I know my y is equal to 20. All right. Let's try a few more here, so we can see that we're doing these ones correctly. What if I had something like this? What if I had, again, 0.4n is equal to 5. Again, sometimes these are tricky because you're like, there's no decimal though, Mr. Leong. What do you mean? How can I move a decimal when the decimal doesn't exist? Remember, every number has a decimal. This one you can say is not just 5, you can say it's 5.0, right? 5 and 5.0 are the same number, right? If I have $5, I have the same as $5.00. I can add an infinite number of zeros at the end. It doesn't change what the number is. Okay, so same thing here. I'm going to move this over 1, and I'm going to move this one over 1. So I end up with, instead, 4n is equal to 50. And that's one thing that, too, if you want to see that you did it right, is you want to make sure that you, a decimal going into a whole number, you're going to get a bigger number, right? It's like saying how much time does like a centimeter fit into a meter? Like there's a lot, right? So you're trying to, when you're dividing, that's what you're kind of doing. So let's just go ahead and finish off this problem. I'm going to divide by 4 on both sides. Now, I don't know what 50 divided by 4 is, so let me just kind of do that by hand real quick. 50 goes in 5 one time. 4, that's a 2. Gotta drop the 0. That's a decimal. And a 5. So there's my final answer. N is equal to 12.5. All right, so that's what you have going on there, and these kind of problems they're a little bit similar. You just have to be, sometimes you have to get a little bit creative with how you do the work here. But for the most part, it's just, again, we don't like the decimals, so we get rid of the decimals. Here's one. How about this? Throwing something a little different. Negative 1.4p is equal to 5.6. So we're gonna do the same thing. Now remember, when I see a negative right here, that gives me an alert. I only see a negative on one side, so I know my final answer is gonna be negative because the other side doesn't have a negative to cancel it out. So my final answer should be negative. I gotta remember that from the first thing. That alert goes off my head that the final answer will be negative. Okay, so let's go ahead and move over our decimals here. And I get 14p is equal to 56. I'm again going to divide by 14. I'll use the division sign this time. Again, it doesn't matter, whichever one you're more comfortable with, either division or the fraction bar, that's up to you. Okay, as long as you're, canceling these out, that's how that works, right? Okay, so 56 divided by 14. I know that 14 times 2 is 28, which is half of 56. So I could have done log division, or I could just say, okay, well, now here's actually, I'm about to make a mistake. I almost forgot about this negative. So again, remember that actually is a negative 14 here. That was a negative 1.4, so it would be negative 14. So I was about to make that mistake. But again, I caught it because I remember the answer should be negative at the end. So even if you forget the negative, at least you know what the answer should be at the end. You could always look back and be like, should that be positive or negative? And you could be able to do that problem. Okay, so that's going to give me my final answer then of p is equal to 4, but that's a negative. So it's a negative 4. Again, I move the decimal on one side to the other. Now here's a good question. What about if the decimal is only on the other side? Like, what do I do with that? So for example, what if I had a problem that looked like this? 5k is equal to 1.5. Now, what's tempting to do, because we did on all the other problems, is move the decimal over. But you actually don't want to do that, because if you move the decimal over, yes, this one becomes 15, which is good, but then this becomes a 50. And we don't necessarily want to do that. So this is what I recommend for you instead, on a problem that looks kind of like this. What I recommend you do is you do just like what we did before with the multiplication, where you just do it like a regular problem, like it's 15, and then you know that you're gonna have to move a decimal over. So what I'm saying is this: we know that's 5k over there, so I'm gonna need to divide by 5 on both sides. So let's divide by 5 on both sides. Now we know that cancels out, and we're just gonna be left with k, so that's great. That's what we want. But over here, I've got 1.5 divided by 15. Well, let's say it was just, or sorry, 1.5 divided by 5. Let's just say it was regular 15. 15 divided by 5 is simply 3. But there's a decimal here, so I need to go one decimal place. So I'm gonna go one decimal place. So my final answer will be 0.3 instead, 0.3. Now, these ones are ones I would recommend you checking, especially these ones, because even I could get a little confused on here. So let's see. I've got 5k. In this case, k is going to be 0.3. Should equal 1.5 if we did it correctly. All right, well, 5 times 3 is 15, but we've got that one decimal place, so I got to go one decimal place here. One decimal place. So I got 1.5 is equal to 1.5, and my answer checks out. Those are the ones that could be a little bit tricky too. So don't move the decimal, only move the decimal rather if it's next to the variable, if it's the coefficient. If it's not the coefficient, I wouldn't recommend you doing it, because then you're just gonna end up with a really, like, a bigger number. I would rather divide by 5 than divide by 50. So that's a kind of a good way to think about that one. One of the types of problems you're gonna see on your homework was just, what if I have something like this? Problems today. Let's say I had m over 7 is equal to 1.1, something like that, right? If you see something like that, again, this is not a reciprocal type problem. This is more of this is a division problem, right? This is m. This part right here is m divided by 7. So I'm going to do the opposite, the inverse, which is multiply by 7 on both sides, right? Times 7, or 7 over 1. Okay, so we know that's going to cancel, and all we'll be left with on the left side of our equation is m. On the right side, I have to do a little bit of work. So maybe instead of writing it under to the side, I'll write it underneath. So 7 times 1 is 7. 7 times 1 is 7. So my answer would be 7.7 there. So try not to get confused with those. Those are not like fraction and decimal problems. Okay, those are mainly like dividing into multiplying still by decimals. That's why it's in kind of this section with that. So yeah, that's where things can get a little bit tricky. I know that sometimes we kind of get our numbers mixed up and things like that. But again, that one's not really dealing with fractions. That's more like dealing with multiplying and then dealing with canceling or multiplying on the other side. Okay, so that's what I want you to look at. Okay, so a couple different problems that we saw, going backwards. So this letter G problem, again, is really just more of a straight multiplication problem. On letter F, again, you don't move the decimal if the coefficient is the whole number. Okay, so the coefficient is the whole number, just divide regular, and then just remember that you have this one decimal place right here. So one decimal place, your answer should have one decimal place. Or two, whether if it's two, then you just have two decimal places, things like that. And then all these other problems, again, try to get it so that the coefficient isn't a decimal anymore. If you need to move the decimal over 1, you're multiplying by 10. And it moves the decimal over 1. If you need to move it over twice, then you're technically moving over times 100. You move it twice. As long as you're doing the same thing on both sides, you move them the decimals on both sides, you're going to be fine. I think the biggest issue that I see when people do these problems is they only move one decimal and they don't move the other one. And then you have to do a little bit of common sense and to see if if the answer makes sense, and double checking your work, doing the check work over here. That's going to help a lot to make sure that your answer is really actually making some sense. Okay, so that's how we do problems that have rational coefficients that are decimals. Again, the goal is to make it so there aren't decimals anymore, and so you just kind of move them out of the way. That's kind of key with that. But you don't always do that. Like letter F, you don't. Letter G, you don't move them out of the way. And then like these last three were kind of different types of problems. Watch out for the negatives and things like that, of course. Okay, so that is the rest of 6.3.